Well, good morning, folks. Happy New Year. It's the 11th of January. Welcome to one of my tent shops. And today is going to be quite a bit different than my normal subjects on this channel. Uh, Quite esoteric, but it is something that I've thought about for decades. And I have a fairly good idea, or a fairly high level of confidence, at least in my own mind, that I'm onto something that helps explain gravity, which is a subject for some reason that I've always been fascinated with. It is combined with a number of other things that have always interested me, particularly the notion of boundary layers. That is a subject that I'll cover partly in relationship to my notion about gravity, but also all by itself. I think it's a very fascinating subject. But this notion of, or my idea of what gravity is, for the most part, what I'm going to talk about isn't particularly controversial. An awful lot of people agree. So the Einstein also mentioned that gravity is not a force, and I certainly agree with Mr. Einstein. The other aspect of it, though, as far as it being a boundary layer, is very, very esoteric. And it's going to be hard to explain it in detail. I'm not a mathematician nor a physicist, astrophysicist of any kind. So I'm stuck with just the English language and a few very, very simple props, which I think are, one in particular that I'm going to show you, is fairly appropriate, I think. So, I am going to expand on why I think the way I do, but this video will be for just the very flat out basic concept of what I'm talking about. So, let's see if I can show this to you. So, my prop is a piece of tinfoil. All right, that's it, just a flat piece of tinfoil. Now, when explaining anything like this, any concept like this, you're left with needing to use analogs of one sort or another. In this case, a prop like tinfoil. Even mathematics, really all they're doing is using a different language than English, certainly more efficient for their purposes than the English language, but really is just another language that is trying to explain something that doesn't fit into any language, really. So, in my case, my simple little prop here, all right, don't think of gravity as flat dimensionally. I'll get to that. But this is I think a good example of what I'm talking about. So this is gravity. All right, it's our plane of existence, not a force. It doesn't actually obey the laws of thermodynamics, if you will. It's not compressible. And it doesn't follow the rules of entropy, in the sense that, like with every other energy source, they all follow entropy in the sense that they go from a high energy state to a lower energy state, or if you want, you can say it's high frequency to low frequency. Very, very hot to very, very cool, right? And it's a continuous decline. So even after we can't detect an energy source, so way below infrared, the energy is still there. It's just a much lower frequency, or cooler and cooler and cooler. All right? Gravity doesn't follow that. Right? Gravity doesn't get weak in that sense. It's not declining in its energy state, although, as we've said, gravity is not an energy, if you will. It's our plane of existence. So, at the Big Bang, right? Imagine we have this piece of tin foil, and we attach a couple of leads to it, and we shoot a whole bunch of energy into it, into the tin foil. And the tin foil holds that energy. Got it? The leads are temporary, so you can disconnect the leads, so there's no continuous feed of energy into this layer of tinfoil. But the tinfoil then holds on to that energy. That's us. The energy that's within the plane of existence, which is defined by gravity, is us. We are all just collections of various frequencies of energy. I know that's a gross simplification, obviously, but that is what we are. We are the energy inside this plane of existence, which is defined by gravity. Now, as I said, the universe isn't flat, and neither is gravity. It may have started out flat, and I'm using the word flat just as a general descriptor, but when the energy shot into it at the Big Bang, it was disturbed, right? And so the universe, or the gravity, got all crinkled up. All right? That plane, that flat plane that you saw at the beginning, is still there, right? And the energy was inside that plane, and it's still the same, essentially the same dimension. Again, that's just a generic term that has nothing to do with distance or volume or anything like that. But this is then the universe. A complex ball of energy that's contained within gravity. Now, in the case of where is gravity then? Well, it surrounds absolutely everything, down to the very smallest possible dimension that we've been able to imagine, which is the Planck limit, which I don't believe exists. I think there is there is dimensionality, if you will, or measurements smaller than the Planck limit. I'll talk about that. But in a nutshell, our universe, the plane of existence that we perceive, and try and describe is contained within um, within gravity, which defines our plane of existence. I'm repeating that, I know. The really difficult part to keep hold of in your mind as a concept is gravity is non-dimensional, and thus the universe itself doesn't have any dimensionality independent of what is defined by energy, the energy that makes us up, and entropy, the function of entropy. That one's really hard to hold on to in your mind for any length of time. But we can compress this down to the very smallest amount, and if you've ever noticed online, the Japanese do something with balls of tin foil, and they compress it, and then they polish the outside so it looks like a solid sphere. Well, you can make it as small as you want, but that original dimensional layer, that flat plane layer, is still in there. I'll be expanding on that to a certain extent over a series of videos. I don't want to make these too long because it's crazy enough as it is, me talking about out in the middle of a winter in a shed that isn't heated. And I do have other things to do, like chop wood. So that's it for now. I will touch on a bunch of things to hopefully justify my crazy idea. And we'll see you again soon.